Okay, here we have an athlete performing what's traditionally known as a B-skip. It's a drill that is used mainly for max velocity running mechanics, something you would use when you're at top end speed to enhance top end speed mechanics and that good efficient leg cycle. This guy's a really high level athlete, Olympic level athlete, and he's already performing at a high level, but I'm going to just kind of show a couple things that I would address with him in order to take him kind of to even a higher level. One of the things here we want to see, which he already has this, is what we call a real good power line, and that's just basically a straight line from the ears to the ankles. That's just about perfect right there. Maximum hip extension, knee extension, and he's got that foot coming off a dorsiflex position, which not shown there, but he was in that position. So power line is really good. He's got that down. Now, one of the things I want to focus on here is more the recovery, ground prep, and actual ground contact. So anytime you're applying force into the ground, you want an equal and opposite reaction that's going to propel you in a direction you want to go. All that means is, what we'll start off here is the negative thigh acceleration is one thing that's really important. So if he's moving forward, which really he's moving this way to his left on the screen, you want that thigh to negatively accelerate, which means it's going to go in the opposite direction that he's going. So you know, a really fast athlete is someone who has really active negative thigh acceleration. Okay, so he's moving forward, thigh's moving down and back the opposite way. The other thing that's real important here, one thing I really want to touch on is ankle position, which dictates foot position at ground contact. So ideally you want to see a dorsiflex foot. So you want to see that left foot there cocked and loaded, and when it comes in contact with the ground you want it to remain cocked and loaded. As you can see here, right at ground contact he kind of loses that and gets into more of a plantar flex position. All this does is basically he loses some of that elastic eccentric load that he had in lower leg musculature when the leg was cocked, or the foot was cocked here. So you want to maintain that cock position at ground contact. And what that does is it allows the foot to contact the ground closer to the base of support. Now, a super strong, fast athlete, which he really is, can get away with a foot that's contacting the ground way out in front of the base of support, kind of here, in that blue. But your younger, less advanced athletes really need to be aware of that foot position in relation to the center of gravity, because they just can't propel themselves forward if the foot is way out in front of the body. And what it does is it applies a braking force and it actually slows the athlete down. So what you want to see is that if that foot remains in that dorsiflex position, it will actually contact the ground a little bit later, more into the red there a little bit, and you'll see better transition and a propulsion off that ground contact if the foot is closer to the base of support. Now again, more advanced athletes can get away with a foot that's way down in front of the body, but less advanced athletes, they need that foot to be a little bit closer. Not directly under the base of support. Let me be clear on that. You don't want it directly under, but you want it slightly out front. Look at it in terms of the stronger, the more developed the athlete, the further out that foot can be in relation to the base of support. And then here's a good example of that. If you look here, now this athlete actually has a little bit of an injury on that right hip. You can see here he really loses. At that point the knee starts to bend and the foot's way out the base of support. So on his right side he's a little more asymmetrical in his ground prep and ground contact phase compared to his left side. And amazingly, this guy is super fast. He competed at the Olympic level, and he makes it happen. So again, I don't know, as a coach, really how much you want to mess with here as far as correcting him, because he's already performing at a high level. But these are just some mechanical issues that you want to be aware of as a coach, as an athlete, and that you can use kinesio capture motion analysis to actually give that instant feedback and show the athletes where they're at in relation to efficient biomechanics.